So the next speaker is Antonio Navarra from CMCC in Italy. Antonio is a long-term friend of Kola and has known Shukla also for a long time. And in fact, when Shukla and I were at ICTP establishing that group, we used to interact with this Bologna group with Antonio. So good to see you again. So he's going to talk, I think, something different than monsoon, right? So the title is Climate Change Finished.
Yeah, of course I change everything, that's my style. But I would like to say a few words because I've known Shukla from the mid-80s. And actually I've been at Kola for some time, but at some point I was back in Italy and the director of my lab called me and he said, well, I'm involved with this ICTP business and I would like to make a summer school. But it has to be international. Can you do anything? And I said, well, yeah, I think I know somebody that can make it international. And so I called Shukla, and then we organized this school, and the Shukla came to Trieste, and thing happened. And yesterday, Shukla said that he had been lucky. I don't think so. Because, of course, luck is the quality of every good general. But luck is the capability of identifying and exploiting opportunity. It looks like luck to the people that outside cannot identify and exploit opportunity. But it's not pure luck. So I think that Shukla has been exceptionally capable at identifying and exploiting opportunity. And also in that case, of course, he grasped it very quickly and created something that still exists. And I think we should be very grateful. So, and the other thing that happened was that in those years we were sort of thinking about doing something to develop climate science in Italy. And of course the model, there was really nothing to invent. The model all existed outside. We were started thinking about creating a national center for climate research, but it was a big project for young scientists. And so we didn't know really, it was a little hesitant. But Shukla provided our existence theorem. If Shukla made it, we could make it too. So that's why we, in the end, we found the courage to start this project that is the Euro-Mediterranean Center of Climate Change. And Italy being Italy, it took us 10 years from the original idea to actually starting the operations. But these things, it exists. And I think he owns a significant percentage of his existence to the fact that Shukla and Kola existed. So I think that's very important. And this, of course, Euro-Mediterranean, that's connection with monsoon, because there is a connection between Mediterranean and monsoon, as the only time that I will mention monsoon in my talk. And I'm very well aware that I'm standing between you and your lunch, so I don't want to really take a lot of time, but I have a message that I would like to transmit. Briefly, the way we create this center was to create we arrived last, so we created an integrated center for climate change, impacts, and modeling. And this is our mission. It was written by a committee, as you can see, and is very comprehensive, but basically says we will try to do everything we can to model everything we can that involves climate, something like that. And actually we did. So we have a very wide range of applications that basically shows how pervasive, as I was saying before, climate is everywhere. And we've been trying to let different communities to talk to each other. And for instance, we have solved only a few months ago the problem of making economic models and climate models to be compatible. One of the main problems is that economic models are not geo-referenced. They basically use administrative boundaries rather than grid points. But now they found a way of putting their data on grid points. And so finally we're starting a project to put together economic model and climate models in a way that I think will be very innovative. But I don't want to make a lot of propaganda. I just want to give you a feeling of what we're doing. This is the structure. So as I said, we have a different number of divisions that go from climate modeling to risk assessments to, as I said, economic modeling and policy analysis. Because the other thing that happened in these years is that we, as Oppenheimer used to say, we have known sin. we had to interact with the policy makers, with the decision makers, and we have been exposed to the mechanism that forms consensus and policy. That is an interesting lesson to be learned. Of course, we got a computer. I don't want to spend much time. And we're doing many things. I just want to show one thing, because we're doing seamless prediction, but we are not doing seamless prediction like everybody else, because we're not involved in weather forecasts, but we're doing that in the ocean, because we do short-term ocean prediction using the same models that then we use in our climate effort. And these are examples of some of our operational system. They do forecast in the Mediterranean, in the sub-basin of the Mediterranean, all the way to very high resolution for application, for adaptations, and other studies very close in the coast and with the rivers upstream. And we have expanded in a number of operational activities where we found applications for the things that we have to develop in order to understand how the weather and climate works. And guess what? We have mobile applications, because you cannot really stay away from the mobile world. So some of this data is disseminated using iOS and Android apps that interact with our central system where the data is staying. And we're now developing a global ocean forecasting system based on our new model. This is a NEMO version of 1/16th resolution that we're now running for about 15 years. That will be the base of our ocean prediction system on the 10 days forecast. We are passing our ocean data simulation on the 1/16. We're in the process of doing that. So just to show that basically we are aware of the kind of activity that's going on, and we trying to find a spot in which we contribute to jobs and growth. That's the mantra, okay? Oh, by the way, of course, the other thing is that we have been developing our own climate model. Recently, we have made, I think, a very unique effort. We have taken the NCAR CSM model, and we have coupled it with our ocean and NEMO model. We're using all the infrastructure. And so we now have a very flexible and unique combination that will allow us, I think, to move to the frontier of research. The frontier of research, that's the other thing. As I said, the exposure to policy has made us aware of the mechanism which create consensus and create support. And one of the things we realized is that narratives are much more important than we thought. You can show all the graph you want, you can show all the picture and everything you want, but if the narratives does really connect you emotionally with the people that are taking decision, you're dead in the water. And the science as an endless frontier is a very powerful narrative, has worked for many, many years. And our field has used very powerful narratives that have supported our social license to operate. So in the 50s, weather forecast was the thing. In the 60s, general circulation models. In the 70s, extended range forecast. In the 80s and 90s, seasonal forecast. In the zeros and tens has been climate change. Now the problem is I don't see as powerful a narrative coming up in the 20s. And this can be seen, there are many signs in the sky, as they used to say. Just one that's familiar to me, if I take the language by which climate goes into our main science program, that's Horizon 2020. There are lots of things, but the interesting things, there are a number of actions. So you can see that climate goes into that climate action, resource efficiency, and raw materials. There's another committee that decided these things, that's clearly. But you say, okay, that's all right, that's just a title. Let's go look at the detail. You go look at the detail. And then it says that basically the objective is climate action, environment, resource efficiency to achieve an efficient climate change resilient, blah, 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 blah. You can read everything. But you see, basically they assume that climate science is sort of finished, it's done. And then you have to develop what are the consequences for a number of other things. So this means we are not as effective in pushing our narratives. people don't think that we are relevant. And of course, this is very dangerous. Let me show you another thing. Look at this data. There is a date that running on the top. You can see data is accumulating as time goes by. And slowly, these things are converging. Slowly, very slowly. This is a pointer. And that's it. Ladies and gentlemen, this is the Higgs boson, this bump. That bump is the most expensive bump in the history of humankind. About $10 billion to get this bump. That's it. That's all the evidence of the Higgs boson. Oh no, I have another evidence actually. You can look it in different channels, so you can have similar plots. Slowly, as that accumulates, you see another bump. It's actually the same bump, but seen in a different way. So, okay, you get two bumps for $10 billion, sorry. So, why is interesting? That's all they have. I mean, they don't have skeptics. They don't have anybody that says, oh, that's not true. You have no particles in your accelerator. It's all a conspiracy to make money and just produce a plot. So, of course, that's convenient. On the other hand, if you look at the data, the distance between this plot and the actual observation is enormous. I mean, there is so much elaboration and data messaging in the middle that we are direct observers in comparison. But nobody questioned this. This is a very powerful narrative. So why something so exotic as an Higgs boson has become such a powerful narrative? Well, I think because it's a symbol, it's a scientific challenge, it has a metric of success contained in it. So once you find it, it's done. You have won. So you have defined at the same time a very powerful symbol, a scientific challenge that's difficult, and also the metric by which you define that you made it. Now, I think we're missing our Higgs boson, and we have to find it. And we have to find it quick. And I don't know which one can be. I think we really need to have a discussion about this, and I would be really happy if you could have a meeting and start, discussing about what it might be. It might be natural variability. Natural variability is an enormous problem. It's sitting there and is affecting all the issue with the climate change. It could be the identification of new challenges from other societal risks that are out there. It could be seasonal cycle. We can decide that we have to make an effort to really break the back of seasonal cycle. It could be ice ages. That's the largest signal in the system, and we don't really have a good theory for it. So I really think that we should have a meeting, and we should try to produce a vision, because we cannot really attract bright people. Yet this morning we're discussing about bright people. If we don't offer them a dream, we have to offer them a vision. We have to offer them the opportunity to be part of something that will place them in history. And I think this is very important. And our advantage, we're very cheap. It's not true that we're expensive. We're very cheap. The astronomers are spending $1 billion to put antennas in the South Africa just to measure something. And there are photo tubes in the sea offshore Sicily in 100 meters square, a cube, just to measure the effect of some neutrinos on seawater. Oh, by the way, they don't have oceanographers on board, but that's another story. So we're really cheap. So money is not the issue. Money is to find a way in which we connect emotionally and intellectually to the people with a narrative that they can understand and they can share. And of course, the real reason for this is that we have to find something for the next 30 years of Shukla career, because he's not done with us, we're certainly not done with him.
Thank you, Antonio. Any questions? Shukla?
I'll think about it.
No, take a question.
I think there's another factor. You had these various factors, metric of success and symbols and scientific challenges. But the Higgs boson came about because the scientific community as a whole, decided that's what they were going to go behind. They had various debates, maybe behind closed doors, but they ended up, as a community, being able to go to their governments and saying, this is what we want. And we don't have that sense of common purpose, unfortunately.
Yeah, I agree with you, Tim. That's why I think we need a meeting for that, because it's a call to arms in some sense. I mean, we need to find a shared idea, a shared consensus, maybe not 100%, maybe 80%, whatever. Or maybe we can agree on two things. But we need to start that process of discussion and debate, because otherwise we will get more and more marginalized.
You mentioned, or you emphasized very much modeling aspects of the center, and you did mention or touch on observations, but I wonder if you could say a bit more about your interactions with the real world and observations and where they come from and whether you make demands of the observations or how you see that interaction.
Yeah, of course we have to decide what we need to do with our limited resources. So of course we use observations. We use all the analysis and reanalysis product, and we do inside the ocean data simulation on both in analysis and reanalysis mode. So we're very much aware of the importance of observation. We simply have to make some choices. In our particular case, we're limited to the treatment of observations with the assimilation systems.
Where do you get it from?
What?
Where do you get the observation?
No. I'm not saying it's not important to fund observation. Don't get me wrong. I totally agree with you that we need to support observations. But for instance, the history of the Tog array is showing us that's something relatively cheap, on the scale of these big science things. But we're in problems. And the problem is we are not capable of finding the right story that will make the whole thing sellable. So the things are connected. I don't want to push only modeling project, not at all.
Sorry, I was wondering if you are thinking of doing strongly coupled data simulation where the ocean sees the atmospheric observations.
Yeah. Probably not, because atmospheric data simulation for us, it's very expensive. So it's beyond our capability. So we'll have to think what we can do. But at the moment, we don't have plans for that.
Antonio,
Yes.
can I ask a difficult question?
Well, of course, all questions are difficult from you.
One of the drivers in developing a medium-range forecast was, of course, to provide something which was useful for society. And that was done in a rather substantial way, I would say. Now, if we look upon climate modeling for the future, and if we take now the climate change simulation studies, which if we take now the ordinary metric of 2 times CO2, where IPCC has summarized the result to be between 1.5 to 4.5 degrees, which is very much similar as Charlie did some 40 years ago, with a difference that he had an optimum value which was 3 degrees, while this time IPCC didn't say anything about it. Now, this is of course a rather awkward situation, because warming of about 1 degree is relatively harmless, while a warming of 4 degrees, 4.5 degrees, is almost a disaster, at least in some parts of the world. Now, we are then in a situation we can ask ourselves, what do we really provide? Is the issue in such a way that we are unable to predict, that we are simply dealing with such a complex system that there is simply no firm solution, and therefore we cannot say anything really of any significance? And I think this is a dilemma which we have to recognize, because if we don't can proceed a little clear there to give a clear message to the users community in the world, we might have some problems in the future.
Yeah, that's true. But don't forget that these are scenarios. They're not predictions. So we're basically making a statement about possible future. not the future that will be. No, it's a value. There's lots of community that can use, from the user point of view, there are lots of community that can insert this information in the more general risk assessment system, and they can use it. The problem is that they must be reasonably, we have to provide them, we have to make sure that we are not leaving out anything. So that if the scenario we're providing is really the range of possibility that is there. That, I think, is the most important thing. Because if we left out something, then the scenario, in some sense, has limited value. So in that sense, the models have a very important role. But from the point of view of our community, in some sense, climate change, as exhausted, is propelling power as a scientific problem. There are lots of work to be done, so don't get me wrong. I mean, lots of work. We have to provide local information, we have to improve that. But as a scientific problem, it's almost finished. We know everything, or we have done all we can. Okay, that's probably, we've been looking after every lamp that is lit, okay? So I think we need to look, we have to go in some other direction, as of course the works go on and things will move on again.
Last question.
Well, I love your narrative in a way, but I think we'd be extraordinarily naive if we did not recognize that the reason climate science is being marginalized has been a perfectly deliberate strategy, because there's incompatibility with an extraordinarily corrupt economic system, which realized way back 20 years ago that unless they marginalized climate science, the economic system, which at the moment would sacrifice the earth for short-term profit and the exploitation of the poor around the world, would lose. And that still is a central truth. And if we just simply ignore that and create another fancy story, it will be marginalized also.
Yeah, well, that's true to a point. I think, even the most cynical corporate leader doesn't want to go into history as the guy that ruined the planet. And so there is... It's more complicated than that. I feel that there is a sense that something needs to be done. And my feeling is that we have to do agreement. And you do agreements with the people that don't think like you. And if we don't get this kind of consensus, then we won't be able to muster the support that we need. So the problem is that to find ways in which we can connect the issue of climate variability, investigation, in some sense, all this science, we have to connect to the values of people that don't think like most of us. That's a challenge. And that's the way to go, and I think that's the difficult part. That's why I think we should start a debate as soon as possible.
Thank you, Antonio. And I'd like to thank all the speakers of this session on Asian monsoon.